Hello, everyone, and welcome to the second webinar for the August series. So in the next 1 hour or so, we are going to learn about Corda accounts. So we'll go into different concepts of account. We'll also do a demo and see how the accounts work in Corda. So my name is Ashutosh, and I am a developer evangelist at R3, and I'll be taking you through the entire session today. And I also have Irina with me, who will be helping me out with answering some of your questions on the chat. So if you feel like there is anything you don't understand, or any such questions that comes to your mind while we are learning about accounts, just feel free to put it there, and she'll be able to answer it for you guys. In the meanwhile, I'll also be looking at the chat from time to time, but Arina is there always for you, with you guys. All right, so with that, let's get started. So yeah, before we start, let's just do a little bit of a, what do we say, a poll to try and understand what kind of audience we have got here. So if you understand Corda and you are like pretty much you know pretty much the basics of Corda, just type in Corda on the chat. And if you are completely new to Corda, haven't known anything about it, maybe just type no Corda, and that will help us understand the type of audience we have in here. There you go. We have Irina welcoming you all to the uh, to the to the workshop today. Yeah, so while we get your responses on whether you guys are good with Coda or not, just for sake of people who have not um, gone through basic concepts of Coda, one thing that I would recommend is we did a very basic sort of Coda bootcamp earlier last Thursday. So feel free to watch that; it's there on the channel recorded. And but for you to be able to understand accounts, it requires a little bit of knowledge of Coda. So I'll just walk through some of the key concepts which we will be talking about later on. This won't take much time for people who already know this. It would just be over in a minute or so. So when you think of Corda in terms of not Corda, Corda is the platform, and when you build a CorDapp, that's what runs on top of on the Corda platform, right? So we have Corda as a platform, and you build applications, and that runs on the Corda platform. These applications we call them as CorDapps. Now CorDapps have basically three major components, which are states. Now, anything that you put in, like Corda is a DLT, right, a distributed ledger. So anything that you put inside the Corda ledger is sort of something that you want to track on the ledger, right? It's more or less an asset. So that's these assets are which we call it states. So states are something that you that represents your asset. You put all your facts on the state, and you record it on the asset. But as like anything that goes into a Corda ledger, these things are immutable and they can't be changed. The only way they can change is by means of transactions. So basically, you do not change something which is already there. You just create an update on top of that, and then you mark the previous one which was there on your ledger as consumed or historic, and you don't use that anymore. While you produce a new output, which is basically your most updated version of that particular asset, and that's being referred to when you refer to that asset for the next time. Now these changes, when you do transactions, you change these assets. They can't just change randomly, right? There has to be certain business rules which you need to follow. These business rules are supposed to be inside your contracts. So we write contracts to which governs the evolution of an asset in a sense. And then we talked about asset. We talked about the business rules. We govern the change of these assets. But you think of any business action, right? Any particular action that you want to take in a business sense, there are workflows which needs to be taken care of. So how do we model these workflows, right? So flows are the next component in your CorDapp, which will allow you to model these workflows. Now, I'm talking about all these things because these are pretty core to a CorDapp, and we will be using these terms while we go forward. And it's important for you to know what these things are, at least at this point of time. Yeah, but as far as I see, most of the people who have responded have said that they are aware of Corda. That's really, really good. And I'm pretty much happy that we'll be able to cover this with people who have good knowledge of Corda at this point of time. But in case you do not have, I think I've done the basics for you guys just so that you know what these different terms are. And then maybe after this session or so, just go through the go through the Corda bootcamp, which we did last month, and you should be good. All right. So first thing is why accounts? Why did we develop accounts? What are the different things that what are the different things that came to our mind when we thought of developing accounts, right? Well, um, when we developed accounts, the most important, or in fact, when we had Corda, right? If most of you who are aware of Corda, the thing is that Corda as a node can only have one single identity or a legal identity, right? Every identity in Corda have legal names and they're registered at the network level. But the limitation is that every node could have just one single identity. And this sort of is okay when you think of big enterprises, which is what Corda was initially designed for. Big enterprises hosting their nodes and communicating with other big enterprises, which is pretty much fine, because you have big enterprises hosting a node and they have their own identities in there. But when Corda started to go out there in the market and people wanted to use it for other than just big enterprises, but rather than bringing it to the normal people, the end users, right? How would a big, let's say a custodian, or let's say a bank who is hosting a node, how would he represent his customers on the node? So that's where we see that as Corda was starting to get more and more adopted in as a more general purpose DLT, we thought the need of having something like accounts which we could use to represent external identities on the node. So that's where we thought of developing accounts. So what that does, it allows even small businesses to just onboard it onto the Corda network or the network of Corda nodes. And then it if you think of these small businesses, what is it that restricts them from running their own node, right? Well, you could have that argument, but if you think of these small businesses, they're not like big enterprises who could run nodes on their own because of maybe the cost issues or some other issues as well, technicalities. You need some sort of little bit of a technical knowledge, or you need a technical team to be able to cater to any issues that comes up, right? So even individuals or small businesses are not supposed to be doing that. So that's where accounts help them, because you could now have an account on a Corda node which is run by another bigger entity, and then you could be able to transact on the Corda network. So that's what we see. That's where we thought of developing the accounts functionality. So all of a sudden, what you see is when you develop a CorDapp, it just scales better, right? In the terms of reaching out more people, so more people could be onboarded and more people could be using your CorDapps going forward. Right. So that's pretty much why why the accounts were developed. Well, I think we have a question here. Will this session have any hands-on? There won't be any hands-on, but we will do a demo. So it's not like the normal boot camp where we code out the entire application, but yeah, we'll be doing a small demo to showcase how accounts work. That will again be based on the bootcamp app which we developed last time in the bootcamp, in the Coda bootcamp, right? Well, yeah. So what exactly, coming back to the topic, right? Thanks, Irina, for answering that anyways. Again, coming back to the topic, what exactly is account from a technical perspective? So accounts are not identities per se. They are not Corda identities, but they don't really subdivide your vault, right? They are logical constructs in a way. So to understand that, let's look at this particular diagram. So you have nodes, and then these nodes have real legal identities which are registered with the sorry with a network identity manager, and then these nodes will have different accounts, right? And these accounts will also have their own public keys, and which they'll use to transact. And these accounts currently are not legal identities per se. They are not registered at the node level. So it's not like you have them available on your network map, but these are just logical constructs available on the node. And when you say we map them to identities, it's not about Corda identities, right? It's more about external identities. When I talk about a bank and its customer, so these identities are identities in an external application, not Corda identities. So you map that external identities to an account on a Corda node. So that's how this entire thing works. All right. So looking at it from a more deeper view, what are the accounts and how are they available? How does the node is divided on the from looking at it from the node's vault perspective, right? So you know that the nodes vault is a single thing. It's not really subdivided based on the accounts, but it's logically divided. What that means is, if you could think of the bigger one here, node vault, this is the entire vault, and then you could say that logically each account will have certain states mapped to them, and there could be certain state mapped to the global identity, which is like the node's identity, right? And then you could have accounts who would be knowing about certain states that are available recorded onto your ledger. And uh, and this entire thing sits on top of two services, which are the key management service and the identity service. So key management service is anything and everything that has to do with storing the keys of the accounts. So these accounts will have public keys or key pairs which they'll be using to transact, and your key management service is the one which is responsible for creating and storing these keys, while the mapping of these keys to the accounts are managed by the identity service. Identity service will have this. It's sort of like a table where it will have the entries which would say that this particular account is having this particular key. So there, that sort of mapping is managed in the identity service. So whenever you create an account, it doesn't really create a key right there. So keys are created when you transact. We'll come to that later on, but yeah. So just from the design perspective, again, the nodes vault is a single identity. There is no physical separation as such, but what you see here is logical separation. You have states mapped to the accounts, but if you are node operator, if I log into the node, I do not and if I look at the nodes vault, there is no separation for me. I can see all the data in there. So this separation from an account level is more of a application level concern. So you'll be provided with APIs which you could use to segregate these different states based on accounts, and we'll see how to do that when you come to the demo. But yeah, this is more of application level concern. The node doesn't physically divide the vault, it only has a logical subdivision, right? So again, few points to note which we already talked about, but these are really important, so we'll just repeat them all over again. Accounts are not Corda identities. So what exactly are accounts if they are not identities, right? Well, accounts are just Corda states. So we'll see, when you really create an account, all that we do is create a state on the Corda ledger, and this state then is mapped to a public key which is generated when you do transactions and other stuff. So yeah, so since they are not identities, there is no network level map or a network map which stores these accounts. They are needed to be shared on a need to know basis, just like states are. And there is no physical isolation of the vault. So the vault is still the same. All the states reside there, but you could achieve isolation from the application level using certain APIs, right? And it's pretty much understandable that you cannot use these keys or the key pairs which are generated for the accounts, and you cannot use them, or basically you cannot store them on HSMs. Why is that? Because generally we create a new key pair for each and every transaction, and then we don't want to store all these keys into the HSM. And why we create new keys for every transaction? That's again for certain security reasons, because the entire key management and stuff is with the node, and we don't want it to have a single key, and then if the private key is compromised, that account could get unusable, or people could use it for for some wrong purpose which is not really desirable, right? All right, so with that, accounts are not called identities, and there is no physical isolation. So let's look at how we could transact with accounts. So taking the example of a 3-node system, or a 3-node network, we could see that what kind of transactions you could do. Basically, you could do all kind of transactions, but this is just to see that whether you could transact account to account to node, or all these things. So generally, if you have node A, which is hosting 4 accounts, and you have node C, which is hosting 3 accounts, C1, C2, C3, node A hosting 4 accounts, A1 to A4. So you could have transactions between A2 to A3 or A1 to A4. So you could have account to account transaction within the same node, right? And then you could also have account to account transaction between different nodes. So account A and account A1 and account C1, which are in 2 different nodes, that is node A and node C, can also transact, while account A1 and A2, which are on the same node, can also transact. And you could also do account to node transactions. So you could also do a transaction which says that 2 parties involved, and the 2 parties are, one is an account and other is a node, which is actually the real identity, or a physical identity, or a real legal identity. So all these is possible. You can have all different permutations and combinations of transactions between accounts and nodes. Right. So possible use cases. This is also pretty obvious when we discussed about accounts in the initial thing. So it opens up the way for custodial sort of relationship, right? Where banks and accounts and brokerage houses who wants to manage accounts for their customers. So these are like custodians of accounts. So this is something which was not possible, or even if it was possible, the identities had to be managed separately in a external application. But now you could actually map those accounts to the Corda node, and the transactions will be done using these accounts as well. So that's an area of use case which can be opened up. Again, you would have things like large companies having different departments, and they could have accounts for each departments, while they host a single node. And then again, various B2C applications, right? Business to customers, where one business want to host a node to cater to its customers. So all these different use cases, which was not possible because there was no accounts library available, are now open, and these all applications could now be built on Corda. All right. So that's, again, it gives your CorDapp a little bit of scalability because it could reach a major mass of people now. So that's pretty much on the theory part. I think I did a lot of explanation on accounts. It's time for us to uh, dive into some of the code and try and see what accounts is actually. Well, under the hood, we have so basically the entire accounts thing revolve around two things, two different basically things, which is like you have the account info and the account service. We'll look at that. So account info is actually the state which I talked about. So when you create an account, what exactly gets created is a state of is an instance of type account info, which is actually a Corda state that gets created and stored on a ledger. And then we have account service, which is more like an interface which provides you certain sort of functionalities which you could access, like creating accounts and other things, like you want to do certain other, like create a key and all these different kind of utility kind of methods which are available with your account service. You do some queries, and also all these things are available with this service. So that's the interface which you use to access all these services. Is there a limit to the number of accounts that can be created per node? So that's a question which we have got. Well, technically no, because there is no limit to the number of states that you could create. Again, it's well, but practically yes, depends on on your on your database size, right? So the amount of hard disk that you have, but that's in practice you could say no. Well then, and then there are certain flows which we have. So these flows are there to make your job easier. So you don't have to, like, if you want to create an account, you want to share an account, you don't have to write your own. You don't have to write your own flows to do that. So the library allows you to write all these, just call few flows and perform all these different common activities which we'll be doing with accounts. And we'll have a look at few of them when we do the demo. All right. So yeah, I already discussed about these. So let's go to IntelliJ and try and see what these things have. right. All right. So let me open up account info. Yeah. So this is the state for an account. So generally when you create an account, it's again just a state which gets created, which is the account info state. And what it has is a name, a host, and an identifier. So what is the name? It's the name of the account. So if I want to create an account with my name, say Ashutosh, then that's the name of the account which gets populated in there. And then the host is the node where your where your account is actually getting created. See, so if I create an account on party A, the host becomes party A, and identifier is just a unique ID to uniquely identify your account. Right. So that's all about it. That's an account state. And then we have the account service, which is interface. There you go. If I open up, there are lot of methods which you could which we have in the account service allows you to it's sort of your interface to the accounts world where we could well, you could basically just go and see what are the different services that this service provides in which you could access. So there are a lot of things like querying, so which you have like account for host, you could pass the party and it will give you a list of accounts, and then all accounts will give you all the accounts that the node know about. You could create accounts, you could get the keys of an account, and all these kind of common functions which you want to access are available in your account service. Which Git repo is being demonstrated. All right, I'll just paste a link. So it's the Bootcamp CorDapp repo. Only thing that changes is it's a different branch. And I'll just give you a link to that. Yep, there you go. So yeah, the README is not exactly updated, but yeah, the all these files that you would see here are available in this repo. We'll take the effort to update the README in some time, but currently the README is again outdated. All right, so that's account info and the account service classes. Let's go back to our presentation. Yeah. So is there a limit to the number of accounts? Well, no, there is no limit to the number of accounts that you would create. Like I said, it's just it's just the states which you create when you create accounts, right? And there should not be any limit to the number of states that you could create. So there is no limit to the number of accounts created that you could create. All right. So let's talk a bit about certain, I would say it's the life, not exactly life cycle, but certain things that you would do when you want to start with accounts. So first thing that you want to do is, if you want to transact with an account, you need to create an account, right? So the first thing that you would do is to create your account, right? So prior to initializing your flow, the first thing you do is create your account. Now, accounts are Corda states. They don't get shared with everyone like normally it like any other normal state. It's not like the identities or Corda identities which reside on the network map and everyone could access it. So if you want to share an account that you have on your node, you have to run a flow to share that account with whatever counterparties that you want to share it with, right? So that's where share counterparty comes in. Right. So if you have an account, it's not discoverable by default. You will have to share that account with other counterparties. All right. We have another question which says, can accounts be used for scenarios where user come to your network website and can register, get configured, set up as an account? Yes, you can do that. You could have if you have a front end where you are where you want the user to sign in. So in that process, you could actually hit the Corda node via the RPC to actually create an account for them as well. Yeah, that can be done. All right. Again, coming back to our discussion, the next thing is, what do you do when you want to have an account, you want to run a flow with that account. So like I said, for every transaction that we do with an account, we it's really recommended to use a new key. So we have a flow which will do that for you. You just request a new key and it will generate a new key for you. It will return the key, and in turn you could use that same key to do the transaction. So it's just like normal, it's just like the normal flow where you use the parties or the legal identities keys to sign your transaction. This time you're going to use the keys of your account to sign the transaction. That's the only difference that comes in. So once you request your key, if there is a counterparty involved, you'll request their key as well, because they also need to generate a new key, right? So that's what you do. And once you have those keys, you can use those keys rather than using the keys of the nodes. And we'll see that in the code as well. And then comes the part of data retrieval. Like we said, there is no physical separation. So we need to create our queries accordingly using the count criteria, where we make sure that whatever we are showing to the end user, we are actually passing in the account as in the criteria, so that he doesn't actually see the data of some other accounts, right? That's how the entire thing works. So let's look all these in practice. Let's do a small demo and try and see how the Corda accounts really work. Okay, going back to idea and explain what we have here. So I just so if you see, it's the same token CorDapp which we built. It's just a little bit modified so that we'll be using accounts. Don't worry about the different number of or just the account had 4 different classes. Like this has a lot more than that, but I've just divided into multiple classes so that things are easier for me to make sure that you guys understand it, and then I'm able to probably describe these different concepts with with each isolated class. So that's why we have multiple classes here, but do not worry, just bear with me. I'm going to explain each and every one of them to you. So yeah, the first thing we need is just create an account. So before I do that, I'll just bring up the network. So I would say deploy the nodes to get my um, CorDapp built and my nodes getting created properly. So once that is done, I can run the nodes. While that happens, what we are going to do is, so I have this particular flow, which will generally not use in this demo, but yeah, what it does, it creates an account, and then it distributes or it shares that account with whatever parties that you pass on to this flow. So to create an account, all it does is it calls a flow called create account, and then it passes the account name. So that will create an account for you, and it will return me a state and ref. Like I said, accounts are just states, so that would return me that particular state and ref for that account, right? And then accounts by default are not available to everyone, so you need to share it. So we do that using the share account info flow, and what that does is it just shares the account with the counterparties that you pass as a parameter to the flow. So that's pretty simple. Just call a flow, a library flow in the accounts library, and that will do the job of creating your account and sharing your account. But but uh, but it's not really always that. Let's say, for example, you are hosting a node and then you have certain internal accounts that you don't want to share with everyone. So you may just have 2 different flows for sharing, creating, as well as sharing the accounts. So that's why I have a share account flow, and the create is actually a flow which I can directly call from the terminal. So I have not really added a separate flow to do that in the CorDapp. But to share it, you can't really call this directly from the terminal, but you could call it if you have a client From the terminal, it's not possible to actually query and then return that result as an input. So that's why we have to write a flow for that here. But you have a client, you could directly call this. You don't really need this flow in your CorDapp, right? So let me explain that while I run the build nodes and run nodes. So that should bring up my nodes. Oops, something went wrong. Okay. All right, probably last time it wasn't properly closed. So I have got 3 parties and I would need a notary, which did not start. So I'll manually start the notary. Okay. Yeah. So if I do a flow list, which will give me the list of all the flows that's registered. So these are the flows which are written by me, but these are all the flows which are available in the Corda library. So if you're using an account, you could directly call these flows, but since we are, sorry, if you're using a client, you could directly call these flows from the client. But since we are not using a client here, we'll be using our terminal to showcase the different concepts. So that's where I had to use this share account flow separately. I had to write it so that I'm able to share an account. But you have the share account info, which you could really use, or which you could really call from your client. But if I say if you look at the parameters that it accepts a state and ref object of account type, which I could only get if I query the vault. Now that's not possible for me to query a vault as well as pass the output of it to the state using the terminal. So that's the reason I had to go with create a separate flow to showcase this thing. But again, that's not required in the CorDapp. You could just call it from your client. Right. Okay. So let's create some accounts. Yeah. So I'm in party A and I'm going to create an account. So I can call the create account flow, which is not something which I have written. There is no create account flow here. Or if I want to create and share it together, I can call the create and share, but let's just create the account for now. So for that, I can use the library flow, which is like this one, right? Create account flow. And that should create an account for me. There you go, an account is created. Let me create one more. Let's call it account A2. And we have got 2 accounts created in our party A. And I will just run the vault query on the account info object. And that should give me the accounts which I have created. See, these are the accounts, 2 accounts created, named account A1, account A2, and then the host is party A, while we have some other few other metadata, which we are not concerned about right now, right? So we got 2 accounts. Now, I said that we could do account to account transaction, we could do node to account transaction. So let's look at doing a node to account transaction within the same node. So I want to do a transaction between party A and an account in party A. Before I do that, let me just explain the flow, because without that you won't understand what's going on. All right. So coming to the, so yeah, first of all, let me explain the state, what changes in the state. So when you want to introduce accounts, we want the account to be a party so that we could actually use that in our state, right? So earlier when we have issuer and owner, these were parties, but then account is not a party, it's a state again. How do I use it as an identity? How would it sign a transaction, right? So for that, if you look at the party class, it has the abstract party is the base class, and then you have two different classes out of that, which is the anonymous party, and then we have a party. So generally we use party class for a well-known identity, which is the node identity. But if you want to represent something like an account, so you could use the anonymous party. What is anonymous party and party? The difference is that party has a well-known identity, a Corda X500 name, while anonymous identity is only identified by a public key, right? So for an account, you need to change the party to an anonymous party, right? That's what I have done here. And the other thing that you could do is I have different things here, right? So issuer is an abstract party while my owner is an anonymous party. Why is that? So try and understand this. So issuer is an abstract party, which means it could either be a party as well as an anonymous party, which means it could actually be an account as well as it could be a node. So I could basically issue a token using an account, or as well as I can issue a token using a node. So the issuer can either be party A or it could be an account in party A. But since the owner's type is anonymous party, it can only be an account. It cannot be a identity or a node. So if you want to have this sort of if you have this kind of a use case where you want a particular field, like for this token we have this issuer and owner. So if you want something to be like a particular action to be taken even by a account and also by a node, so use abstract party. And if you want only accounts, you can use anonymous party. But generally it's good to use abstract party. Why? To restrict it from using one or the other, right? So this was just to showcase how you could what's the use of anonymous party and what's the use of abstract party. But yeah, if you use abstract party, you could use it as a account as well as you could use it as a well-known identity. So let's see that. Nothing changes in the contract. What changes in our flow, right? So we are taking an account and we are taking the owner account here, and we're taking amount. So we say who is the issuer of the token, which account is issuing it, which account is actually the owner, and what's the amount that we are issuing. But we have two different constructors here. So two cases that comes up earlier. If you forget about this one, so this is what we used to have in our normal token issue, where we infer the issuer as the current node, which is basically, that's why we don't really take the issuer as an input, because we know that whichever node is triggering this particular flow is actually the issuer. So we don't really need an issuer from the as a parameter, and that doesn't need to be typed in by the person who is calling this flow. But if it's an account, it could be an account on the node, and we don't know which account, so we need this account to be passed in. But the other constructor is taking care of the case where you are issuing the token as a node. So this is where we are taking care of the situation where party A is issuing a token to an account within the node party A, right? So this is what we are doing here. And simple change that happens here is all right, we get the notary, which is pretty much what we need in any case. We need a notary to do a transaction. But then here there is something in terms of accounts. I said that whenever you do a transaction with account, you need to request for the key, right? Whenever you created a account, you just created a state on the Corda ledger. What about the key which this account will use to sign a transaction? So whenever you do a transaction, you request a key. So that's what I'm doing. So issuer party, issuer has two cases. It could either be an account or it could be a node. So if the account is null, which means I am not passing the account, I'm using this constructor. So I want the issuer to be the node itself. So I use our identity, which is basically the node's identity. But if the issuer is actually an account, then I need to get the party for an account, which means I need to get the anonymous party, which will contain the public key for the account. So I pass in the issuer account to this function, which I have here. And what that will do is it will use the account service to get the account info, and then with that account info object, we could call the request key for account flow, which will request a key and it will return the key wrapped in the anonymous party object. All right. So again, let's just talk through this all over again so that things are more clear. So issuer here can be a party as well as an account, because issuer is in the state, issuer is an abstract party, which is the base class. It could either be a party or it could be an anonymous party. Party is used for legal identities or node identities, while anonymous party is used for accounts, because uh, party is identified by a key, a public key, as well as a legal identity or X500 name. But your account anonymous party is only identified by a public key, right? Which is what your account is. It doesn't have an identity or a Corda identity per se. So when we talk about the flow, our owner is always an account, but our issuer is probably an account, or it could be a node as well, or a node or a real identity rather than an account. So two functions. If it's account, we need to pass the account name. We don't know which account we are referring to, because there could be multiple accounts which could be issuing it. But if it's the party, then we infer that the party is the node who is issuing this token. So whoever is running this particular issuance flow is the party if he is hitting this particular constructor. So coming back down here, we need to, if we are considering of using accounts, we need the key for the account. So for the issuer, if it's not an account, we say give me the identity of the node, and if it's an account, we say um, give me an anonymous party for this account, which is the anonymous party is your key is the wrapper of the account's key, which will be just generated. And in order to get the key, we need the account info class, which we will get using the account service. To get the account service, just use the utilities and you get the sense of the account service. With the account service, you could say give me the account info, and it will return you the account info from the vault, which you could pass on to the request key for account, and that will return you a key wrapped in the anonymous party object. Right, we do a similar thing for the owner party, and going forward everything is pretty much similar. You just create your transaction at the output at the command, and we make sure that we are using the accounts key if it's the account rather than the nodes key. And then you verify the transaction, you sign the transaction. Again, we use the account key to sign the transaction if it's an account. And finally, we collect the signatures, which is again the same. We do nothing other than passing the correct keys. And finally, there is a little bit of thing here which we need to do if we are if you're transacting on the same node. Now we cannot pass the session of the same node to the finality flow. We can't really create a session with ourselves in finality flow, but there are two cases here, right? In the finality flow, it could be a case that I am issuing a token and I'm using the same account, right? The same node. The entire transaction is within the same node, maybe two accounts in the same node, or an account and the node itself, or it could be the account or some other node, or the node, and it could be an account in the node A and it could be an account in some other node. So it involves a transaction between a single node or a transaction happening across two different nodes. So if it's a transaction happening across two different nodes, we need to pass the session of the other node. If it's not, we don't pass a session, because you don't really create a session with yourself in your finality flow. So that's what we are doing. We just check that who is the node of the account, of the owner account. If the owner account exists within the same node, that is the host is us ourselves, then we do not basically pass any session. But if it's a node in some other node, if it's an account in some other node, then we need to pass the session. So that's the difference that we have to take care of, right? That's it from the flow part. Let's run this flow then. Okay, so there is a question which says, um, are there any other config needed to be done to set up accounts? Well, yes, you need to add certain things to your build.gradle file, which is, it's accounts are just libraries, right? These are CorDapps. So you need to add these CorDapps, which are uh, the account contracts, the account workflows, and accounts depends on confidential identity. So you'll have to add those confidential identity um, dependency as well. Well, if you go to the accounts, just let me ping it on the chat. So if you go to your hold on, GitHub on yeah, so if you go to this particular link, this is the GitHub for the account project. And then you will scroll down in the README, you'll find a section which talks about how to add the account dependency onto your own CorDapp. So that's pretty much self-explanatory. It just explains every different dependency that you need to add to your build.gradle, and that should be it for you. Okay, another question says, does anonymous party key needs to be set up in the node.conf? No, there is no need to set up anything in the node.conf if you're using accounts. All right, yeah, so let's run the demo. All right, so where were we? We just created 2 accounts, and then we want to do certain transactions, let's say. So I'm going to issue certain tokens. So let's say I'm using the issuance flow to, so in this case, I'm not using the issuer account, which means the issuer is party A itself, while the account that's the owner is account A1, right? My transaction is done, and let me do another transaction. There you go. So 2 transactions. So we have issued 2 tokens to account 1 A1 and account A2. One to account A1 and one to account A2. So let's have a look at the vault. Remember, I'm the node operator. I'm operating the node, so I would be able to see everything. So two states. You won't see the actual account name here, but the anonymous, since the anonymous party is actually a wrapper um, of your public key. So this is a hash of your public key, which you actually see, the hash of the account's public key, which was generated for this particular transaction. While you could see the issuer, because that's a node, which is party A. But like I said, segregation or isolation of the vault from is account is a application level concern. So you could write queries that will do that. So I have a query for that, which says query by account, and if I pass the account name, say A1, then that gives me just one account. See, the owner is account 1, while there is the other one. It will never return you the other account. It will just return you the states which this particular account is or this particular account knows about. Similarly, we could do this for account A2, and you will get the other token state which was issued to account A2. All right. So that's transaction on the same account or the same node. Let's do a little bit extra. Let's do a transaction between 2 accounts on the same node, right? We did the transactions, which was the transaction between the party and the account on the same node. But let's do a transaction between account A1 and account A2. There you go. So that's the transaction, and I should be able to see 2 different states now, because again, remember, issuer and owner, both of them are the parties to this particular token state. So A1 and A2 both should be able to see the new state, which was with new token state, which is an amount of 300. So A1 is able to see it. A2 should also be able to see it. Yeah, there you go. That's it. So that's it from the single node perspective. Let's try and do something from a different node. Let's try to do it with, let's create some accounts in the other node. Let's go to party B and create a few nodes here, or few accounts here. So I created account B1, and now can I do a transaction between account B1 and my node party A, right? So what I'm doing is I'm using the issuer as the node, and I am issuing the token to account B1, which is on node B, node or party B. It doesn't work, right? Because account B1 does not exist for node A. The account is not shared. Like I said, these are states and they need to be shared. So for that, I'm going to call the share account flow from node B. And what I'm going to do is I'm going to share this account, which is B1 with party A. I hope this is big enough now. Right. So the account has been shared. Now I should be able to do the transaction. There you go. The transaction is done, right? So let's query it. So we should know about account B2. So we should be able to query account B2. Is that, oh, sorry, B1. Yeah. So I know about account B1. And if I go here and I do the same thing, it's already created. Need to query. Yeah, there you go. So we are able to do transactions between nodes and between two different nodes, while with one party on the node being an account and the other party on the other node being the node itself, which is party A. So another case, let's do a transaction between two accounts on two different nodes. But for that, I need to share my account A1 with party B, right? He doesn't know about account A1 yet. So shared. Now let's do the transaction. Just copying the commands which I've written down. All right, so what is this going to do? Well, this is going to create a token with account A1, which is on node A as the issuer, and account B1, which is on party B as the owner. Account transaction successful, which means I should be able to see, if I use account B1, I should be able to see an token with amount 500, right? Yes, that's there. And again, this should be true for A1 as well, right? Right, that's true. So both of them has the token with amount 500. Similarly, we should be able to do the same with our party B. Yeah, so he can see the token with amount 500, and A1, there is nothing. Why is that? Why does A1 shows absolutely nothing while A1 does have a few states, right? And if you notice, you don't really see who the issuer is in the previous one as well for B1. Well, why is that? That's because since these keys are generated on the fly while we do transactions, uh, at times you could have a a syncing problem between two different nodes, right? So each and every time you do a transaction, you create a key and you store it with yourself, and then you sign it, while probably your counterparty, you're not sharing that key with your counterparty, so your counterparty doesn't know about the mapping of your key with your account, while this guy does have the token state. If you see that, so you should see a token state. Yeah, so this is the one, the 500 one. So this guy has the token state, but he doesn't know that this particular key, whom does it belongs to, whom does that key belongs to, because this key was not shared with party B. So that's where we need to run something called the sync account flow, which will sync these nodes keys, and once that happens, you could actually be able to view all your data properly. So let me run this. So account A1 is not properly synced because the problem was with account A1, and it needs to be synced with party B. The account is synced properly now. And you could see that A1 has all the data. Also, B1 has all the data properly. Again, you don't really need to run the sync flow separately. It needs to be part of your main flow, right? And to understand this, let me go back to the code. What your sync flow is actually doing is it's calling something called share state and sync account flow. And what it does, it just shares, it just syncs all the public keys across two different nodes, right? So in general, if you look at this flow, which is so there is one difference. There is other flow which I've written, which says token issue flow with sync, right? So what this does is it does one extra thing, which is this part here. So what it does is it shares the state and sync account once the transaction is done. But I just wanted to show you guys this issue. So I created a state with a flow without including this particular piece of code, which wasn't syncing the different nodes with the accounts. So that's why you are seeing that particular issue. While if you sync the accounts properly, that won't happen. Again, to showcase this, let's go back to our terminals. And let me go back to party A and run this again. I'm doing a new transaction. So this time the amount is 600 and the account involved are A1 and B1. Transaction is done. And if I do query for account A1, he sees 600. And if I query the same thing in party B, he wouldn't see 600 because of this syncing issue, which happened because I did not share because I ran the flow which didn't have the sync code in it. Let me just go ahead and not this one. Yeah, this is the one. Anyways. Yeah, so let me sync it again, and you could see that your 600 comes up again. But this would not happen if I run the sync flow, right? So this time the flow is different while the parameters are the same. You could see that I'm running the token issue flow with sync. So if I run this, now the amount is 700. So I should be able to see the 700 here, while should be able to see the 700 here as well. So that's how you do. There is this extra piece of code which you have to write to sync the accounts when you're doing transactions between accounts in two different nodes. Well, yeah, that's pretty much it. I guess we are done for the session. Also, we are on time. Well, let's go back to our slides and see to just do the final thing. And if you want to try all of these yourselves, there are a few samples which are out there on the samples repo. The links are there. Just go in there. The accounts library or the accounts library itself, I have shared the link, and we have samples in both Java as well as Kotlin, which you could find in these respective repositories. So these are the different applications which are, there is a supply chain application, and then there is a TikTok toe game. We have named him TikTok Thor because it was developed by one of our engineers named Thor. So just giving some sort of naming to it so that his name comes up. Yeah, and then we have a World Cup ticket booking system, which was built using tokens, and it also has accounts integrated with it. So if you're a guy who wants to know how to integrate tokens and accounts together, so the World Cup ticket booking application is the one which you should try to look at. Well, that's it. Before we close, here is a few things about the next webinar or the next workshop, which is something on CorDapp testing. We're going to show you how to do proper testing of your CorDapps, how to write your unit test cases, integration test cases and stuff. And that's going to happen next Thursday, 2 p.m. same time. It also happens in New York, in New York, local time, that is 2 p.m. there as well, and in India time, 2 p.m. Also, since you have learned so much about Corda, you want to continue your journey, try to go into the free training site, which is training.corda.net, and you would find a lot of materials there, which would be useful. We also have a separate section for accounts there. Corda Ledger Slack, great place for everyone to be there to talk to us as well as other fellow Corda developers. Everything about Corda is in the Corda docs. GitHub repo is there if you want to look at the platform code that's available in the GitHub repo. It's open source. If you want to contact us, you could write to us at devrel@r3.com. If you want to tweet, just tweet with our handle, using a handle @Corda blockchain and @inside R3. Do use the hashtags #Corda and #R3. YouTube channel, you already know. Make sure you subscribe so that we can come up with new videos and webinars for you guys and you don't miss these. All right, thank you so much for joining, and I hope to see you again in the next webinar. All right, bye-bye.